Hi, today's video is going to be like a small life hack with digital clocks. So it is a pretty common hack which most of the electronic enthusiasts can use, and it can help you save the trouble of resetting the time every time you replace the batteries. Let us get started with it. Okay, so a lot of us use digital clocks these days. The digital clocks help us in many ways. They show us the day, the date, temperature, humidity, and they also show us like the time in minutes, which is very important in today's very fast life. I do agree that we have mobile phones and laptops which already show us the time, but still everyone has a few of these digital clocks lying around the place. The main problem which these digital clocks have is that when we remove their batteries and fix it back, the time that we have set gets reset. It again gets back to 12:11 and all these things, and we have to reset it again, which is not very convenient for us. So in today's video, let us take a look at how we can solve this problem. Okay, so the first order of business to use this life hack is to make sure that the batteries that you use in your digital clock are rechargeable type, nickel metal hydride type specifically. These batteries look similar to the normal alkaline batteries, but they are nickel metal hydride and they are rechargeable. Do not attempt this hack with alkaline or carbon-zinc batteries, as it could result in explosions and other disastrous consequences. Only try it if you have a battery that is nickel metal hydride, that is, it specifically says rechargeable over here. Okay, so the circuit that we are going to use for this hack is known as a DC to DC step down converter. It basically takes a higher input voltage from this side, it may or may not be constant, and gives out a continuous output voltage from the output. This makes sure that you can reduce your input voltage to a specified output voltage by tuning the potentiometer over here, which may help us get the desired voltage level irrespective of the input voltage of the power supply. I'll make a detailed video on DC to DC converters for a later video, but for now I'll just show you how you can wire this up. Okay, so here I have a lab bench power supply which is set to an output voltage of 5.6 volts, and it is currently drawing 20 milliamps because I've connected this to the DC to DC step down converter. Now you need not use a power supply like this, just give a 5 volt USB input, that would work more than enough. But for now I'm using this power supply just as a demonstration purpose. So coming to this DC to DC converter, you can see that I've already set the voltage to 2.8 volts approximately. One thing is that this voltmeter is slightly faulty while displaying accurate values for lower voltages, which is why it keeps fluctuating, but I have set it to exactly 2.8 volts. Okay, so now I have taken the multimeter and I'm going to measure the voltage across the output of this particular DC to DC converter. Okay, so if you see the multimeter, you can see that's giving exactly 2.8 volts approximately on the multimeter. Always use a multimeter to measure the output of your DC to DC converter. Do not trust these onboard voltmeters as they are pretty inaccurate. So the multimeter confirms that it's 2.8 volts. So now we are set to start the life hack. Okay. So now that we have set the voltage to exactly 2.8 volts, what we need to do is open the battery compartment door and keep it aside. Now if you notice here, this part of the compartment connects both these batteries in series, whereas if you look at this is like two individual terminals, which implies that this is the place where the power flows into the clock, whereas this is just for connecting the two batteries in series. Now we are not supposed to plug it here, rather you will plug this here. Plug the negative of the converter here and the positive of the converter over here. So you can use these jumper cables which are commonly used with breadboards and microcontrollers to get a better grip in these areas, since crocodile clips will not fit and soldering may not be very easy here. So now I'm connecting the positive to the positive, and the negative is also getting connected to the negative. So now what is happening is the battery is getting recharged from the output of this DC to DC converter. It's getting recharged the similar way that it would get recharged if there was a charger. Reason why I've given 2.8 volts is like for two batteries in series, 1.4 volts multiplied to 2 is 2.8 volts, which is why I'm giving 2.8 volts. If it's a single battery, you can go with 1.4, 3 batteries you can go with 4.2, and based on the number of batteries, you multiply the number of batteries to 1.4, and that is the output which you should set the DC to DC converter. But you should make sure that when you are setting that particular output voltage, the input voltage should be much higher than the output voltage. Of course, within the limits of the converter. I'll make a separate video on that like I said before. Okay, so let me just get a multimeter and see with how much current it is recharging. Fine. Now I have my multimeter in the picture. I have connected it in the current mode and set it to 10 amps. Negative terminal is still connected, but for the positive, I'm going to connect the multimeter in between this positive terminal of the battery and the positive terminal of the converter, and let's see what happens. Okay, if you notice here, the total current that is flowing is 40 milliamperes, 0.04 amperes, that is 40 milliamperes is flowing from the converter to the batteries. So since these batteries are around 600 mAh, it would take approximately like 12 hours, that is half a day, to recharge them completely. And it is like, but it's better than removing these batteries, because setting the time again is a tedious process. If required, we can also connect this setup permanently to the system, and it would still power the clock without a problem. Fine, I'm concluding this video for now. Thank you so much for watching. Like, comment, share and subscribe. I will see you in the next video.